Hello guys, welcome to the first video of this series on Introduction to Numpy package in Python. So let's begin. First to discuss, what is Numpy? Numpy is the short form of numerical Python. It is a Python package used to work with arrays and matrices. Using Numpy, we can create one-dimensional, two-dimensional, three-dimensional and even n-dimensional arrays and matrices. But mostly we work with 1D and 2D arrays. Now I am sure you will have a doubt that Python supports list data type, which gives more flexibility such as storing different data typed values, and also Python has many list methods to perform various operations. So why are we learning NumPy? Let's do a comparison between NumPy and lists so that we can know why we need to learn NumPy over lists. When it comes to lists, they occupy more space because they store size, reference count, object type and object value, thus increasing the number of bytes required to store a list value in the memory, and also the values are scattered throughout the memory. But whereas in NumPy arrays are similar to arrays in C, that is, they are of fixed size and store only value in the memory. The values are stored in contiguous fashion in memory. In lists, they perform type checking while accessing values, whereas in NumPy it does not perform any type checking. We can't multiply two list elements directly. Some separate code is to be written for that. But whereas in NumPy, operations on two list elements can be performed without any issues. Element-wise operation is not possible in case of lists, whereas in NumPy, element-wise operation is possible. Final point. List operations require more time to execute than that of NumPy operations, whereas NumPy operations are computed faster than list operations. Now to prove that list takes more time to perform operations as compared to NumPy, let's look at some code. First of all, I have imported two modules, namely NumPy and time. Next, I have created a variable named size and stored a very huge value in it. Next, I have created two lists of range size. Further, I took a result list which will store the multiplication of those list elements. Then I have recorded the initial time of execution. Now further, I have performed the multiplication of those two list elements and stored it in the result list using the for loop. Finally, I have printed the time taken by list to perform multiplication using time.time minus start time. Now to check the time taken by NumPy, I have created two NumPy arrays using the arrange method. Now I have recorded the initial time of execution of these NumPy arrays. Next, I have created a variable named C which will store the multiplication of those two array values. Now finally, I have printed the time taken by NumPy to perform that multiplication operation in the same way we did before, that is time.time minus start time. Now we can see that the time taken by list to perform multiplication is nearly 1.25 seconds, whereas NumPy took only 3 milliseconds to perform that operation. Now let's compare the space occupied by a list and a NumPy array in memory. First, I imported the modules NumPy and sys. Then I created a list and a NumPy array of equal size, that is 3, and stored the values 1, 2 and 3 in them. Then I printed each list element size using sys.getSizeOf method, and then printed the entire list size by multiplying length of L1 into sys.getSizeOf. Now I printed the each NumPy array element size using a.itemSize and the entire array size using a.n bytes. As you can see in the output, the each list element occupies 88 bytes of memory, whereas the entire list occupies 264 bytes of memory, which is quite large. Now the list element size may change on the type of value you store in them. Whereas only 4 bytes of memory is occupied by a NumPy array element and a total of 12 bytes by the entire NumPy array, which is very less as compared to that of list. Now let's look at some applications of NumPy. Mathematics. NumPy can be used to perform matrix and array operations as mentioned before. Plotting graphs. In Matplotlib, some cases of plotting graphs requires NumPy operations. Backend. Now if you remember, I said Pandas is built over NumPy. Not only Pandas, there are other tools and techniques such as Connect4, digital photography, which uses NumPy in its backend. And last but not least, that is machine learning. NumPy is used in steps such as data preparation, data cleaning, etc. Now coming on to installation of NumPy package, as I said before, Jupyter is a very popular Python IDE and doesn't require installation of many popular packages. But if you are using Python ideally, the process is same as installation of Pandas as discussed before in my previous video. Now if you haven't watched that video yet, then please watch that video. I have already mentioned the video in the iCards. The only change will be the command, which will be pip install numpy. So that's it for today. We will dive deep into NumPy in the upcoming videos. Till then, goodbye and stay tuned with us.